Okay, at time t equals 0, balloon A has position vector 3i plus 4j minus 5k, and balloon B has position vector I minus 5j minus k. Balloon A is moving with velocity 2i minus 2j minus 3k, and balloon B is moving with velocity 3i plus 2j minus 5k. Part A then says, show that A and B do not collide. Okay, in order to do this, right, what we need to start with is we need the position vector of balloon A and the position vector of balloon B at any specific time t. Alright? And in order to do that, we go with the velocity that balloon A and balloon B each have, okay? Because remember, the velocity determines the direction it's going in, okay? Determines what's actually happening to the object. So we can see here the balloon A has velocity here, so I could write that down, couldn't I? VA, okay, and I'm going to, obviously I need to underline it because it's a vector quantity, and I'm going to put a subscript there of A because we've got balloon B as well. So balloon A, the velocity will be 2i minus 2j minus 3k, alright? Now, what we need, as I said, is the position vector. This is all very well, this is the velocity, but we want the position vector. So in order to get the position vector, in terms of thinking now in terms of displacement, we'd need to integrate, wouldn't we? Okay, we need to integrate this because this is the velocity. To get the displacement, we need to integrate. Now with vectors, okay, our position vector is always in terms of r, okay? Alright, that's our position vector, always. Right, now we're used to using s, okay, s for displacement, or x even, okay? But when it comes to vectors, we always use r. So I could rewrite velocity A as the derivative of r with respect to t, okay, with r is the position vector. R is the position vector of A at time t. In other words, r is the displacement of it at time t. Okay, so the velocity then would be the derivative of r. So I could just rewrite that, and then when because it seems I want r, I need to integrate, so I'll separate the variables. Okay. And when you integrate, then you get RA this side equals 2ti minus 2tj minus 3tk. Alright, so you're integrating with respect to t there, the ij's and k's stay in place, but don't forget as well, of course, you need to put a constant there, that's so important. Constant there we can work out because it says at time t equals 0, balloon A has position vector 3i plus 4j minus 5k, so we could say that when t equals 0, RA equals 3i plus 4j minus 5k, so you can put that in to here, into this line here. So of course t is 0, all of that will vanish and you just get c then, okay? So RA will equal all of that basically, 2ti minus 2tj minus 3tk plus then the c. What we could do is put the i's together, right? So you've got 2t plus the 3, okay, I, and then the j's, okay, so put a plus here, the j's, then you've got minus 2t plus 4j, and then the k's, I'll put a plus again, you've got minus 3t minus the 5 then, okay. Alright, so yeah, make sure there's a plus in between each I, J and K's, okay? And any minuses, keep them in the bracket, okay? That's the best way to do this. So that's the position vector of A at time t. Now we need to do the same now for B, okay? So we have drb by dt. Velocity of balloon B is that, 3i plus 2j minus 5k. So when you separate the variables and integrate, okay, you get RB equals 3ti plus 2tj minus 5tk. Okay, got the answer down there. Plus, of course, then the constant. All right. Now, perhaps I'll call the constant this time d. All right, because it's a different constant to the last one. All right. Last time we had a constant c there. So now we'll have constant t here. And I'm underlining them because they are going to be vectors, alright, as you see now. So when t equals 0, RB equals, well, where was it when t was 0? It says there, it's got that position vector I minus 5j minus k. So that means then, chuck it in here, I minus 5j minus k, well, they all go to be 0, yeah, when time is 0, so that equals d. So your RB then, position vector of RB will be 3t plus the 1i here, so 3t plus 1i, and then you've got 2t minus the 5 from here, j, and then you've got minus 5t minus the 1 from here, k. Alright, so we've got position vector RA, and we've got position vector RA and RB there, and they're obviously really important now to go in on to answer question A here. Show that A and B do not collide. Okay, that's what it's saying. Now, in order to show that, right, what we should do is we need to sort of assume actually that the opposite is true. Okay, so what we'll do is we'll think, well, let's suppose that they do collide. Okay, so we could say that suppose A and B do collide. We assume the opposite. In other words, okay, we could say RA will equal RB, alright, for a certain time, yeah? Yeah, that makes sense, doesn't it? I mean, if they're going to collide, when they collide, their position vectors will be identical. RA will equal RB for certain time t. So what we could do is literally put their position vectors at time t. Okay, so we've got that one there for RA. Put them equal to each other. Okay. Put that equals to RB's, which is down here. No, I'm not going to quite fit this on. Okay, now if they're equal, easily done now, what you can do is you just equate, that should be I there, shouldn't it? You can just equate the i's, equate the j's, equate the k's. Just equate the i's, you've got 2t plus 3, okay, so the i's from here, you can write that by the side if you want, to equate the i's, 2t plus 3, because they're equal, 2t plus 3 has to equal what's in front of the i's here, 3t plus 1, okay, and also the j's and the k's as well, okay. Let's work out what t would be from here. So that means you'd have 2 equals t. Yeah, straight away they get the time up for to be equal to. Now if we create the j's, we need to get, obviously the time needs to be the same, doesn't it? Because RA will equal RB. That means I, j's and k's have to equal for the same time. So if we put that equal here, then you get 9 equals 4t, which implies t equals 9 over 4. Alright, now clearly the times are different, aren't they? So that means they can't collide. Okay, times are different. In other words, the i's are the same for RA and RB, but the j's are the same for RA and B at a different time, so they're not going to collide. Times are different. Therefore, balloons do not collide.